Okay, so for unit 9, for the normal distribution, we're going to start talking about the C-score value. Now, C-score is going to be a fraction. To begin with, we're going to start with a fraction, and that's going to give us a number. Now, what I'm going to do to be able to solve for my C-score, I'm going to do x, the value that we're checking, x minus my average. Remember how we started using last semester the Greek letters mu? So x, the value that I'm checking, minus the average, or x minus mu, and divided by the standard deviation. And remember, I use the Greek letter sigma, standard deviation. Okay. X, again, is the value that we're checking, minus the average divided by the standard deviation. We're going to do that. That's going to give us a decimal. Notice it's a fraction, so on the top is considered a group. So I'm going to do the subtraction first. And then I'm going to do the division, right? A fraction is division. And again, this is going to give me a decimal, sometimes a whole number. Sometimes it's positive, sometimes it's negative. And that's going to be my C-score. So let's take a look. A normal distribution of scores has a standard deviation of 8. Okay, so for the first two examples, 8 is going to be my standard deviation. Find the C-scores corresponding to each of the following values. A score of 60, where the mean score of sample data value is 40. Okay, so X is 60, right? That's the number that I'm checking. My mean, my average is 40. And then remember, my standard deviation is 8. So I'm just going to go 60 minus 40. And whatever I get, I'm going to divide this by 8. Okay. 60 minus 40 is 20. 20 divided by 8 happens to be 2.5. Okay, not bad. I said we could be dealing with decimals. Now here, let's see question B. A score that is 13 points below the mean. Oh, this is very important. That means that x minus mu is equal to negative 13. Right? We were already told that. A scored that is 13 points below the mean. So x minus mu is negative 13. Oh, it says rounded to the nearest 100. Okay, so that means I'm expecting a big decimal. Okay, so I'm just going to go negative 13 divided by 8. Remember, my standard deviation was 8. Now, negative 13 divided by 8, I get negative 1.625. And then I know it said it to round it to the nearest 100th. Okay, 100th. I know because it ends with a TH, I know it's a decimal, but it sounds like the number 100. Okay, the number 100 has 2 zeros. I'm looking at the amount of zeros. There's 2 of them. So that means my answer should have 2 decimal places. Okay. However, I do take a look at the third decimal place. It is big enough, right? Big enough means 5 or more. Because it is big enough, it's going to push my previous number up. So my number will be negative 1.63. Okay, not bad. Let's take a look at this other 3 questions here. 3 students take equivalent stress test. Find the C-score for each student. Remember my C-score, I'm going to go x minus mean divided by standard deviation, or x minus mu divided by sigma. Okay, so the score I'm checking on A is 144. A score of 144, that's my x, on a test with the mean of 128, that's my mu, and my standard deviation is 34. Notice how I label each of my numbers that I'm going to need. So I'm just going to go 144 minus 128 divided by 34. And this gives me 0.47. Okay, not bad. Let's take a look at example B. A score of 90, so that's the number I'm checking, on a test with a given mean of 86, so my mu is 86, and my standard deviation is 18. Boom, again, let me label them so it's easier for me to see. So I'm just gonna go 90 minus 86 divided by 18. And that's gonna give me 0.22. Not bad. The last example here, a score of 18 on a test with the mean is 15 and my standard deviation is 5. So I'm gonna go 18 minus 15 divided by 5. And that gives me 0.6. Okay. C-scores are not that hard to solve, not that hard to work with. So x minus mu divided by sigma.